The principal investigator for the SEIS team said, "We've been waiting months for our first Mars quake. It's so exciting to finally have proof that Mars is still seismically active. We're looking forward to sharing detailed results once we've studied it more and modeled our data." Mars doesn't have tectonic plates, which Earth has tectonic plates, and that's what causes most of Earth's earthquakes. They get a kind of quake on the moon and on Mars that's caused by faults or fractures in their crusts. And as heavy masses and slow cooling add stress to the crust, it cracks, releasing energy. And detecting these quakes was a real feat of engineering. And on Earth, high-quality seismometers are often placed underground to insulate them from changes in temperature and weather. But it can't be done on Mars, and as a result, it has several ingenious barriers, which has a cover, which is built by JPL, called the Wind and Thermal Shield, to insulate it from the planet's winds, dust, extreme temperature swings, and other sources of noise. And to date, the SEIS has surpassed all the team's expectations in terms of its sensitivity. President of the CNES commented that the French SEIS seismometer is the cornerstone of space cooperation between France and the United States. The instrument has barely begun its mission, and it has already hit pay dirt with this world first, revealing new insights into Mars, a planet that was habitable in its ancient past. The teams at the SISMOC Mission Control Center in Toulouse are working around the clock to operate SEIS and analyze the data beamed back from the Red Planet. Once again, congratulations to all of the scientists and engineers to whom we owe this fantastic success on the surface of Mars. Antoine Petit, who is the CEO of CNRS, said that Earth is no longer the only planet continuously monitored by seismometers. The SEIS instrument deployed on Mars at the start of this year is now recording the slightest ground vibrations day and night, be they due to the atmosphere and its winds sweeping the surface or to quakes and meteorite impacts. Mars is thus the third rocky planetary body in the solar system to be studied by seismologists, 130 years after the beginnings of instrumental seismology on Earth, and 50 years after the first seismometer developed and deployed by Apollo 11 in July of 1969. No fewer than 11 CNRS technologies, in partnership with universities, are working with these exceptional data. In the months and years ahead, their research will tell us more about how Mars formed and why its volcanic activity ceased to leave the cold, dry desert surface we see today. I'm going to play you an actual sound of a Mars quake now. So this audio has 3 different parts. The first part of it is Mars wind. So it sort of sounds like, whoo. That's my closest that I can get to it. And in the middle, it goes a little bit deeper pitch and goes a little bit louder. And then that stops, and then there's the robotic arm from the science device. So listen to this closely, and in the middle, you'll hear the Mars quake. So pretty cool stuff. And JPL is going to continue working on the InSight lander and working with the French teams to have more SEIS data and more on Mars quakes in the future.